Hi, this is Dima Brook, and today we're going to speak about Solidity and how it stores data in its smart contracts. We will need this information in our future video in order to see how to compress data in a smart contract and how to store it more efficiently. Especially, we will look at how the standard ERC721A does it, how it saves, and how it reads the data. So in order to do that, let's start by creating a new file here in Remix. Let's call it, let's say, test contract.sol. Okay, so this is a valid contract right now. We can see that the constructor will consume 12,666 amount of gas. Let's start with some basic types like unsigned integer to 156. Now let's make it public for now. And let's call it my var for my variable. Let's set this variable here in the constructor. Let's set it, let's say, to 56, for example. And we also can optimize it. 200 is usually too low, so let's do 1000 at least. And let's compile the contract. All good. Let's deploy it. There we have it. So here we have our variable, which is set at 56. Let's see how we can read the same variable from code. So we can take the contract address, we can write here in the terminal web3.ethers get storage at, then we provide the address of the contract, and then we provide the slot. Well, because this is the first variable of this contract, the slot will be 0. Let's see what we got there. And we see that is 38. Let's go and convert it. Okay, here's the converter. And we see that it's exactly 56. Let's keep adding more variables here. For example, let's add an address. Let's call it, let's make it public. Let's call it admin. And let's make our admin anyone who called this constructor message sender, like so. And obviously this is going to be our slot number 0, and this will be slot number 1. Let's see if this is the case. Let's compile. Let's transact again. Right, now we have two variables, admin and my var. So let's provide a different contract address here. Okay, we can't get access. Let's try. Now let's try accessing the second variable and let's see whether it allows us to access the first variable or not. Okay, so we have the address of the admin, but it's slot number 1. Let's see whether we can access something in slot number 0. And yes, we can. So this explains that if anybody ever accessed the storage of the smart contract, then we're able to access all the variables. Well, obviously, in order to access the second slot, let's replace 0 with 1, and here we have the address. Let's now try and change this one to private. So basically, I'm not supposed to see what happens in this variable because it's private. Okay, let's now recompile. Let's remove this one. Let's say 56. Let's redeploy. And there we go. So let's see. This is our zeroth slot, we don't have access. Okay, we had access to slot number 1 and so you see what happens. Now we can read the 0th slot. It is private. We are not supposed to have access to this, but we still do. Okay, so now you know that it's possible to read private variables even though you're not supposed to be allowed to do so. Right, let's move on. Also, the point of this video is to understand how the smart contract stores information. So basically, it has a 2 in the power of 256 number of slots, where every slot is of type byte 32. So you see this unsigned integer of 256, it is exactly 32 bytes. The same is with the address. You see the address here, it occupies less than 32 bytes. But what happens is, in order to fit in the slot, the beginning of the slot is padded with zeros. And that can be a big problem. So we have to store a lot of zeros, we have to transfer a lot of zeros, and that provides a huge overhead. Well, with address, it's not that bad because we are populating with meaningful information more than 50% of the slot, but with numbers, it's less so. So, as you can see here, we only use several bytes to store this information, but it occupies an entire slot of 32 bytes. Okay, it's a huge waste of storage and a huge waste of bandwidth to send a lot of zeros back and forth. Okay, so let's move to slot number 3, like so. And here we'll do something interesting. We will try to use this slot for multiple variables. Let's see if it's possible to do it here. So, unsigned integer 64, let's call it A, and let's assign 1 to this so that it's easy to find. Let's copy paste it several times to avoid annoying boilerplate. C and D. Let's set different values to each variable so that we can be sure where it is stored and how it is stored. Let's redeploy. Let's remove the old one, like this. Let's access at least something so that we are sure that we can see that. And let's grab the new address here, like so. Okay, and we remember that this is supposed to be address number, actually not 3, but 2, because it's 0, 1, 2. Right, so let's access number 2, address number 2. And what we see, this is D, this is C, this is B, but where is A? And let's try and look at slot number 1, like so. And seems like this is the address, but be attentive. The address begins with 5B, or where do we see 5B? So here it is. So our A was compressed because it fitted together with the address, like I told you. An address, it occupies 32 bytes, but the meaningful part is just a bit more than 50%. So all the rest are zeros. And Solidity was smart enough to fit in this variable right in here. Okay, so this is another interesting thing that we just found. Okay, the next thing, let's go to slot number 3 this time. And here we will store an array. Let's call it unsigned integer 256. It will be an array. Let's make it public so that we can verify it. let's call it my array, and it will be equal to 1, 2, 3, 4, 5, 6, and 7, like so. Right. So accessing arrays is a bit different from accessing individual variables. In order to do that, let's also create a bytes 32. It's going to be a constant so that it won't occupy any of the slots. We can even mark it as no slot here to be sure that we shouldn't count on this. And let's make it public so we can access it. Let's call it slot because it's a constant. Let's make it all in capital. Slot 3. We assume that this is slot 3. And this is going to be calculated like this. We're going to take this hash function and then ABI encode our slot number 3, like so. Okay, so here we have to be good to go. Actually, no, we also have to write a function, get array element, and here we're going to need inside integer index. It's going to be a public function because we're going to call it from outside. It's going to be pure because it's not modifying storage. It returns bytes 32 because it's a slot, and here it will return let's again pack it into bytes 32 inside integer to 156, and here we will put our slot 3 like so. But because we want to be able to access each individual element, we will add the index here. So this index will be responsible for accessing elements, and the first part will be responsible for accessing the entire array. So what happens is this slot number 3, it holds the link to where this array is stored, and this is how it is calculated where the array starts being stored, and then we just add an index to this value and we can access each individual element here. Right, so let's recompile. Let's remove the old one. Let's transact. Okay, now let's see. This is my array. Let's try and access, let's say, element 0. And here we got 1. Let's try and access element 3. And we got 4. So now we know what to expect. So let's get our function here. Let's provide the new address of the contract. And let's access, first let's try and access slot 3. Let's see what we're going to see there. I'm sure we're not going to see anything. But actually no, we see 7 there. Alright. Let's now try and use our function. So this is the hash of our slot, just in case, and let's try and get an array element. For example, we want to get an array element 0. Okay, so here's the address. Let's take our function and replace this hard-coded float with the hash function. And we got 1. Okay, let's now say 4, for example, not 3, like we did here, because now we're going to get 4. Okay, we just got recalculated this hash. Let's replace it here, and we got our 4. So this is how we can access different elements of an array in a smart contract. What is interesting is that all you need for this is just the address of the smart contract, and you have to calculate the hash of a slot. So you can do it externally, and then you can access arrays of variables of a smart contract that somebody else deployed, not even you. Okay, the next thing we're going to do is, let it be slot number 4, is we're going to see how mapping is stored. So let's create a mapping of addresses mapped to assign integer to 156. Let's make it public, and let's call it balances. So this will be imaginary balances of some accounts. We will imagine that they have some tokens. To avoid some boilerplate, I'll copy them from a different contract, like so. Okay, so whenever we deploy the contract, this balances mapping will be populated with this information. Right, but now in order to access those, we will also need to write another function. Function get mapping element, and here the key will be our address. Let's call it key, and then the second parameter, let's call it inside integer 256. Let's call it a slot. We will make a slot variable because maybe we will have many mappings. It will work with any of those. Again, it's going to be a public pure returns function. It will return the address bytes 32, like so. And so this time it's going to return a chunk to 156 ABI encode. So here we have to provide the key and the slot together. And let's see how it's going to work. Compiling. Okay, so these are the balances. Let's take the first key, and we see that this address has this amount of tokens. Now let's try to access this from our function. Let's replace the address here, and the hash has to be calculated. So get mapping. Here let's provide the same key, like so. So let's assume it is slot number 4. Let's get a hash of it, like this. And we have some response. Okay, let's check what we got here. And great, we have this number. Let's try some other address. Now we don't have to remove the slot because it's stored at the same slot. Okay, but you see the hash is quite different now. Let's get this. Replace the hash here and check what we got here in return. 501, and this is exactly what we expected. So during this video we figured out how Solidity stores data, how we can access it from external libraries, and we will need it in our future videos to understand how smart contract storage can be optimized and how it is done in one of the smart contract standards that we support. Thank you for watching. Don't forget to subscribe, and see you next week.